Okay, so we know the derivative of the function is 4x times x minus 6. I guess it kind of got cut off. So at the factored form, we're looking for critical values. Well, all we've seen is a polynomial, so we know there's no places with the derivatives undefined. So all we got to worry about is where does that equal 0? And we know it equals 0 when x equals 0. We also know it equals 0 when x equals 6. So the whole process of this first derivative test is, make yourselves a little number line, and 0 and 6 are the two zeros, the two critical values. And now we're going to test values in between these intervals. So let's go less than, I don't know, negative number. How about negative 10? Well, if it's negative 10, that 4x times negative 10 is negative, and negative 10 minus 6 is also negative, so that makes it positive. So that tells me f, the function that this is the derivative of, is increasing from negative infinity to 0. Now I'm going to pick a number between 0 and 6. Did they have us do one? Yeah, 0 to 6. They said evaluate 1. So they said use 1. We could use anything. We could use 3. We could use whatever. But what we're going to see is, so when if x equals 1, as they did, that's going to be a positive. 4 times 1 is positive, and 1 minus 6 is negative. So that's going to give me negative. So that tells me the function is decreasing between 0 and 6. Now we'll pick a number greater than 6. Why not 7? We could use 10. If I use 7, 4 times 7 is a positive number. 7 minus 6 is also a positive number. And we know when we multiply two positive or positive, it's positive. So the function is increasing after 6. So without, we don't know much more, at least I'm not seeing much more that's being given. So I know it's decreasing, or it's increasing. This function is increasing on negative infinity until 0, and we'll do it open because it's equal to 0 at 0. So it's not a closed interval, it's an open interval. And then or 6 to infinity, and then we know it's decreasing from 0 to 6. And the reason, so the other thing I want you to think about, where this is increasing because f prime of x is positive, and this is decreasing because f prime of x is less than 0. Okay, we could have done this. I mean, I'm just saying, they asking you to do more than this. And actually, I would have done precisely this with this function. But sometimes I realize, oh, I understand that this is just a parabola, 4x squared minus 4x. I know it crosses the x-axis at 0. I know it crosses the x-axis at 6. I know it opens up because 4 is positive. So I know this function just looks like this. This derivative looks something like this, where it's positive left of 0, it's positive right of 6, and it's negative between 0 and 6. You see how we're getting the same results without having to do the number line? So that's another way to do it. The number line is a nice way to show what you're doing. On the AP test in calculus for high school students, they can't just, it used to be they could just do that number line and get credit. What they want them to do now is to justify how it's increasing by making this statement like, here, let me get my highlighter. They want them to make a statement like this, and it's honestly good form. I mean, I'm not going to require that you do this, because I don't think your Calc 2 instructor will require this. But it's good to add this, because that way you know. Okay, so hopefully that explains why we picked 7. We could have picked any number. Any number bigger than 6 would have worked.